Foxy, go ahead. All right, first thing, take out the 2015 pre-response.
What is that?
Driver, I corrected it. Here is your projected AP score.
Gotcha.
We laugh.
I love policy for the exam, I promise.
What is it? Where's her go?
Is Hernandez here?
Nice!
What do I
Damn, I saw that
do?
one.
Did I give this back to you? I guess not. Okay, look, last year's exam. This is probably the most important thing you need to study.
At least class is peaceful today, yeah.
Will it though?
Well, we'll see about that.
Will it be though? Since
Our friend Lee is not here.
Not Matt Hart.
Okay, do we have this is the one I graded last week, and I told you this is the most important thing. Okay, we're gonna go over every single problem. Warner, pay attention.
Wait,
Look, if there's just one thing you're gonna study,
free
this is it right here. This is last year's test.
So
This is
that,
last
literally,
year's
is that
test.
the one with our projected score?
Yeah, the one with the projected score on it.
Hey.
If you understand how to do every single problem on here, then I don't need to worry. But I need to worry.
I'm just gonna talk super loud in class.
Look, you see this kind of problem, number one. You see this kind of problem where you have things going in and things going out. This is like the third or fourth time we had it. And some of us are still befuddled, so we gotta get this out. And at least we gotta get the points that we can get. That's the thing. Okay, so the rate at which rainwater flows through a pipe is given by this. This is a rate. And then some of you are doing crazy things, though it wasn't of this problem. The pipe is partially blocked, allowing water to drain out the other end of the pipe, modeled by this. So this is the rate at which water is coming out of the pipe. There are 30 cubic feet of water in the pipe at the very beginning, so this is gonna be part of it. Is that chilly?
Should I smell it?
And 11 more.
Ooh.
This was like right when I walked in the door.
How many cubic, now some of you are not reading this. It says, how many cubic feet of rainwater flow into the pipe? Not how much came out of the pipe, how many flowed in. Well, if this is the rate at which water is flowing into the pipe, how do I compute how much water went into the pipe from 0 to 8? You just do an integral from 0 to 8. You write that down on your paper, you get 1 point, you punch it in on your calculator, you get the other point. That would be the two easiest points, right, on pretty much the whole test. Okay, but some people are not reading, and that's causing major problems. Is the amount of water in the pipe increasing or decreasing at time t equal 3? So all you have to do is compute R of 3. This is the rate at which water is flowing in, and compute D of 3. That's the rate at which water is coming out, and then just compare them, right? So if you do this on your calculator, this one comes out to 5.086. This one comes out to 5.4. So this is the rate at which water is going into the pipe. This is the rate at which water is coming out of the pipe. So is the amount of water in the pipe increasing or decreasing? Look at the rate at which it's coming out. Isn't it more than the rate of it coming in? So what? What's the answer? Increasing or decreasing? Decreasing, because all you have to say is because D of 3 is bigger than R of 3. Because, in fact, you don't even have to use the word because. Just say D of 3 is greater than R of 3. That's 2 points, right? Another 2 points right there. See, you got to get the ones you can get because they always put a hard one in there. Okay, C. At what time is the amount of water in the pipe at a minimum? Justify your answer. Now, a lot of people got 0 on this one. A lot of people got 0 out of 3. Now, how do you do this problem? Okay, let's say A is the amount of water that's in the pipe. How do you write an integral that represents that? Or a function? I kind of gave it away by saying integral. Okay, the integral from 0 to t of R of t minus d of t dt. Do we have to put the plus 30?
No.
Yeah, because it says the amount of water in the pipe, so it actually should be plus. But you see, that part of the problem is not that important. Does everybody understand it? This is the total rate, the rate at which it's going in. Now, if you want to, you can split it up into separate integrals. You can go, this is the rate, and then you do an integral, so that's how much water went in, and then you can do an integral for that, and that's the how much water came out. But then if you just subtract the two, I mean, you can just make one integral, just like that. Okay, but anyway, so how do you find the minimum amount of water? What do you do? What do you do to find maxes and mins? You gotta take a derivative and make a number line. So if you take the derivative of this, of course the derivative of 30 is 0. How do you take the derivative of an integral from a constant to something? You take that and plug it in, so you just get R of t minus d of t. In fact, you could just come up with that just by thinking about it, right? What's the total rate? Wouldn't it be the rate going in minus the rate going out? I mean, you could have just gotten that without even doing this. But you need to make a number line for this. Okay, so if you graph this on your calculator and make a number line, it goes like this: 0, 3.272 if you round off, minus plus. So this means the amount of water is decreasing here and it's increasing there. So at what time do you have a minimum? Well, at 3.272. And what's the reason? Because A prime changes from minus to plus. That's what you gotta say on your paper. Just like we normally do. That's 3 points right there. Okay, and then D, if you kind of thought of this beforehand, then that's kind of like leads to D right there. The pipe can hold 50 cubic feet of water before overflowing. When T is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. Well, you started with 30 cubic feet of water, and then how do you figure out how much water went into the pipe? See, this is what I do. I say, well, from 0 to 8, how much water is in the pipe? Isn't it integral from 0 to 8 of R of t minus d of t? See, write down, some people are just leaving it blank. Okay, now what about after this time? When t is greater than 8. Right, but do not solve in the time W when the pipe will begin to overflow. So from 8 to whatever time this is how much water is in the pipe then. And then afterwards I realized, oh, I could have just gone from 0 to W. So why don't we just do that then? 0 to W. See, but you gotta start writing things down. That's the key to doing a lot of these problems. Write it down. And we want that equal to? When does the pipe start overflowing?
50.
At 50. Boom! 2 points right there. See how it involves an integral? So if they tell you involving an integral, that's kind of like a hint. There's going to be an integral in there somewhere. Because some of you didn't even have an integral. It's like, they're kind of... Okay, but get the ones that you can get. This, like I said, this is like the third or fourth, like, things going in, things going out. The key part of the problem here, the meat right here. See, the total rate is the rate of the thing going in minus the rate of the thing going out. That's the total rate. So if you ever want to find the max or min, this is the derivative, and you need to make a number line for that. Okay, now we're going to get it again on Wednesday after school, because I got another one. This is from 2014. We need the same thing. Hopefully we can do it then, and then we can do it on the test. Okay, this is the, oh my goodness, had so many people not reading directions on this. You guys are just giving away points. Okay, so R, well, what's the first curve? How am I gonna draw this like that? And this, and look, they even tell you this is 2, 4. So this is the graph of F, this is the graph of G, and then, you know what? We'll get it. And then first thing you gotta do is you gotta compute that point of intersection, which is 1.0328319 comma 2.401181. Okay, because all the points of other points of intersection are given, right? This is 0, 2, that's 2, 4, this is region R, this is region S. A, find the sum of the areas of R and S. Okay, now some of you are not writing integrals. The answer is only 1 point. You have to show an integral or a derivative. This is a calculus test. That's what they're testing. Now, how do you find this? Now, if you say that this is A and this is B, then you can reduce the amount of writing that you do, right? So how do you find this area here? Top minus bottom, so you can go g of x minus f of x, multiplied by the width dx, add up all of these rectangles from 0 to A. Then, how do you find the area of this region? Top minus bottom, so now it's going to be f minus g. So f of x minus g of x, multiplied by the infinitesimal width, add up all of these rectangles from A to 2. You write that down on your paper, you get 2 points. Punch it in on your calculator, you get another point. Actually, this problem was worth 4 points. I wonder how they split it up. Anyway, the final answer was 2.004. Maybe it was 3 points for setting up the integral. See, that's why you don't write an integral down, you just got 1 out of 4 points. That's good. You don't want that. Okay, B. Now look at region S is the base of a solid. So just this region here, some of you are like doing the whole thing.
Is that what this is? Does that say read?
Yeah. Either that or it says red. But I think it says read.
I think you spelled it wrong. It says R-E-E-D.
I'm not gonna walk over there.
Look.
Who cares if I spelled read wrong?
300 verbal.
No, that's an A.
No, it's not.
It's an angry A. Because you guys don't read. So just this region, cross sections perpendicular to the x-axis are squares, find the bottom of the solid. So you make the rectangle. The length of the rectangle again is top minus bottom, which is f minus g. That's the side of the square, and then you gotta square it. Then you want, now some of you are still not writing the dx. You guys are playing with fire. And then you integrate from A to 2. So you write that down, you get 2 points. You want the third point, you just gotta punch it in on the calculator, and you should get 1.283. Okay, C, a lot of people is, what? Let H be the vertical distance between the graphs of F and G. Find the rate at which H is changing when x equals 1.8. So that right about here. How fast is this vertical distance changing? So this is a related rates problem, okay? How do you do related rates? It's in the notes. It tells you the 3-step process. First step, write an equation. What represents the height, this vertical height here? Isn't it just top minus bottom? Okay, so which one's on the top? G and f of x. So g of x minus f of x. Okay. Now we're doing related rates, so what do? You take the derivative, right? So h of x, h prime of x is g prime x minus f prime x. You just got yourself 1 point there. And they want you to find the rate at which h, but this is not related rates, I'm sorry. It says, find the rate at which h changes with respect to x. So we're just finding the derivative with respect to x. So all you have to do here is plug in 1.8 for x. G prime of 1.8 minus f prime of 1.8. Punch that in on your calculator and you should get negative 3.812. Now some of you are giving units when it says, it doesn't say to give units. And then when it says to give units, you don't give units. Now who is that called? Driver? It was Park. Yeah, it was Park. That's just bizarre. If they don't say to give units, don't give units, because if you volunteer the wrong units, they're going to take off a whole point. That's like 11% of the problem. It's kind of bad. Okay, the rest of the test is no calculator. To me, it's better without a calculator. Okay, I'm not going to write the chart down. So from 0 to 40, Johanna's velocity is given by a differentiable function v. Selected values of V are, use the data in the table to estimate, okay, this is a 1 point, it's either 0 or 1. I think everybody got this. Now, they want you to estimate V prime of 16, which is the slope at 16. Now, is 16 on the chart here? No, so you have to use the two values that surround 16, which would be 12 and 20. So just make sure you do this correctly now. Y minus y over x minus x, and just leave it. Just leave it. You get 1 point. It's either 0 or 1. Some people, well, I don't think anybody's doing it anymore. Some people before used to go x minus x over y minus y. That's not good. Okay, using correct units, see, it says to give units here. Explain the meaning of this. Well, hopefully we know this by now. What happens when you integrate the absolute value of the velocity? That's the total distance traveled in meters from t equals 0 to t equals 40. That's what you should say on your paper. You have to mention the word meters. Approximate this value using a right-Riemann sum with the 4 subdivisions indicated. Okay, now some of you made a slight mistake over here. How far is it from 0 to 12? 12. Who's the guy that always writes just 12 minus 0, and then that's you, yeah? Sakihara. That's fine. Yeah, so if you can't count from 0 to 12, then put 12 minus 0, by all means. And we're using a right endpoint, so then use the right endpoint, which is 200. Next, from 12 to 20, how far is that? 20 minus 12. That's what Sakihara does. But I think we can just put 8, and then we use the right endpoint. How far is it from 20 to 24? 4. Now, what do I use? 240 or negative 220? No, neither. It's positive 220. You know why? Absolute value of the velocity. A lot of people put negative 220 there, 1 point off. See how they try and get you? And then the distance between 24 and 40 is 16, and we use the right endpoint. No, there's no parentheses here. And you just leave it. Don't even attempt to simplify that. Okay? This is 3 points for that part. C, Bob is riding his bicycle along the same path. Bob's velocity is modeled by this. I'm not going to write it down. That's Bob's velocity, measured in minutes, and B of t is measured in meters per. Find Bob's acceleration at time equal 5. So if this is his velocity, all you got to do is take the derivative and plug in 5. Maybe I need to write this down. So you guys better get these 2 points right here. Because I think even Mississippi will get these 2 points. So this is his velocity. His acceleration is the derivative, which is what? 3t squared minus 12t plus 0. And they want you to plug in 5. So 3 times 5 squared minus 12 times 5. Some of you didn't have balls, so you just left it like that, which is fine. But come on. 75 minus 60, 15. Now, should I put units on this? No, because they didn't ask for it, but I think a lot of people put units. Don't risk it. And then D, based on the model of model B for part C, finds Bob's average velocity. Now again, what does this is 3 points this problem. What does average velocity mean? The average value of the velocity. So how do you find average value? 1 over b minus a, integral from a to b of the velocity dt. You write that down, you get 1 point at least. Okay? Average means average value. Because some people weren't even doing an average value. Yeah. Okay, so here we go. T cubed. It doesn't matter. As long as we can do it on Thursday, I'll be happy. Okay, so how do we compute an integral? You gotta find the antiderivative. 1/4 t to the 4th minus 2t cubed plus 300t from 0 to 10. And I noticed a lot of people didn't have balls on this one, so they went like this: 10 to the 4th over 4 minus 10 to the 3 times 2 plus 300 times 10 minus 0 plus 0, and that would be fine. That would be fine. You don't need balls on this test. You just gotta be smart. Anyway, if you did have the balls to simplify it, it came out to 350. But I would just tell you, don't do it. Just leave your answer like that. Okay, this one was kind of disastrous, this problem. But that's okay, as long as we learn from it. You didn't take the real one yet. Oh, and then some of you, oh gosh, I can't believe what I'm seeing. You guys are just playing with fire. Okay, on the axis provided, sketch a slope field for the given differential equation at the 6 indicated points. Then how come some of you giving me 8 slope field, 8 slopes, and there's only 6 points? You guys are killing me. Look, look, they even put the dots, look, here, 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 and here. These are the 6 dots. Some of you are drawing slopes here and here. The thing didn't even have a dot for it. Well, if you do that though, it better be correct, otherwise you take off points. Anyway, look, this one is 0. This one was I forget what the numbers were, but it should look something like that. So this was 2 points. So it's not 1 point for each one now. It's just once you make 2 mistakes, the problem's gone already. You get 0. Okay, part B. Find the second derivative in terms of x, y. Here's the first derivative. dy dx equals 2x minus y. So, doing implicit differentiation, y double prime is 2 minus y prime. Remember, when you do implicit differentiation, the derivative of x is 1, the derivative of y is dy dx or y prime. I don't care which one you write. But they want you to put it in terms of x. So, what can I substitute for y prime? 2x minus y, and if you want to distribute that minus sign, you can, or you don't have to. Okay, there you go, you get 1 point for that. Now, the second point comes from, determine the concavity of all solution curves for the differential equation in quadrant 2. Now, in quadrant 2, what can you say about x? I think we went over this last week, so it sounds familiar. In the second quadrant, x is negative, and y is positive. Now look, if x is a negative number and y is a positive number, what can you say about this number? It's going to be positive, right? So y prime is positive in quadrant 2, which means what? What does that mean? Which means y is concave up. Oh, I guess we shouldn't say y. Maybe we should put curve. That would be more correct. Okay, and then C. Let f of x, now some of you are trying to solve the differential equation. You can't. You cannot solve this differential equation because you cannot separate the variables. So some of you are like just making up your own thing. No, you cannot solve this equation. You cannot. Okay, so y equals f of x is the particular solution. F of 2 is equal to 3, initial condition. Does f have a relative min or max at x equal 2? So how do you determine if you have a max or a min? You gotta look at the derivative, right? Well, if I plug in the point 2 comma 3 into the derivative, what do you get? You get 4 minus 3, which is 1. So if the slope is 1 there, what? Neither. So neither a max or min, because f prime does not change signs, right? It's just 1. Okay, so that was an easy 2 points, but here, I want to mention something. What if they said, what if instead of the point 2 comma 3, see, if I were writing this problem, I would say, what about the point 2 comma 4? You have a max or a min there. Park. Well, if you plug in 2 comma 4 into the derivative, what do you get? You get 4 minus 4 is 0. Oh, so there's a possible max or min there. So how do you tell if you got a max or a min? I have a feeling it's coming up in this year's test. This is my feeling. How do you tell?
A smaller number.
You know, you look at the second derivative. What is the second derivative at this point? 2 minus 2 times 2 is 4 plus y, which is 4. What does that come out to? It comes out to 2. Is there a max or a min there at that point? Look, if the first derivative is 0, remember the slope is 0, and the second derivative is positive, which means the graph is concave up, what does that mean? There's a local minimum there, and what reason do you put? Because of the, what is this thing called again? The second derivative test. That would have been a much better problem for C. I don't know why they decided to do that. And then D, only one person in the, I think only one, did you get it? No. I think only Amano got it. That was you, right?
Wait,
That was pretty amazing. Did you get it?
C?
Yeah. No, part D.
C, no.
Yeah. This is hard. This is a hard problem. This is a bit, like, I think less than 1% of the students in the nation got this.
Wait, the answer is.
Amano is in rarefied air there. Okay, determine the constants M and B for which y equal mx plus b is a solution to the differential equation.
Oh, F.
Okay, now,
Obviously.
first of all, how do you find the slope? How do you find the slope right here? How do you find the slope of the tangent line? The derivative. Here is the derivative. Okay, but then here's the derivative. Right. Y prime is equal to 2x minus y. Okay? Right? But what is y equal to? They just told you what y is. Mx plus b. So you just kind of plug it in, because this part was worth 3 points. You just never know what they're going to give a point for, so like write something down. Because some of you just left it blank. Okay, now what? Distribute it. So what do you got? 2x minus mx minus b, and that's equal to m, right? That's the slope of the, so this is the derivative, but that has to equal to the slope of the tangent line, but since it's this line, this is the slope. So you set them equal to each other, and then now you have to solve for m and b. Now, let me show you something. If ax plus b is equal to 5x plus 4, what can you conclude from that? A must be 5 and b must be 4. What do we call this? We did this in pre-calculus last year. Didn't come up this year now.
Logic.
No, it's called equating the coefficients. Does that sound familiar?
No.
Or how about common sense? If ax plus b equal 5x plus 4, doesn't that mean a gotta be 5 and b gotta be 4? Doesn't that just make sense? So that's what you're doing over here. So m is equal to, now if you gather the two x terms, you're gonna get 2x minus, no, what am I saying, 2 minus m minus b. So on this side, this is like 0x plus m. So, using common sense, 0 must be equal to the coefficient of x on the left, gotta equal to the coefficient of x on the right, and the constant on the left gotta equal to the constant on the right. But then look, I can solve for m in this equation. M equals 2, plug it into here, therefore b must be negative 2. Now that's tough. That's tough. That's a really hard problem. That's why you gotta get the ones you can get. No, for real, because sometimes, you know, there's 9 points for each free response. Like this one, I think the national average was only like 1 point something out of 9. That's because pretty much everybody lost the 3 points in this one. So that's why if you want to get in line for a 5, whatever the national average is, you gotta be above that. You gotta get the ones you can get. What time is it? Yeah, we're on number 5. We're getting there. Code red! Isn't that the code red? Yeah, I'm not gonna put the numbers in, I'll just leave it like this. This is the graph of f prime now. Okay, A. Find all x coordinates at where f has a relative maximum and give a reason for your answer. So we need a number line for f prime, but this is the graph of f prime. It's like you graphed it on your calculator. So where does it touch the x-axis? Here, here, and here. Where would that be? Negative 2, 1, and 4. Above, below, below, below. No, it stops at 4. This is 4. So there's nothing there. Okay, so what does they mean? F is increasing, F is decreasing, F is decreasing. So they're asking, where does F have a relative maximum? Right there. At x equal negative 2. Because, what's the reason? Driver, what's the reason there's a max at negative 2?
Because f prime changes from positive.
There you go. F prime changes from positive to, I think almost all of us are on board with that one now. So good, we got 2 points. B, on what intervals from negative 3 to 4 is the graph of f both concave down and decreasing? So we need to make a number line for the second derivative. Okay, now, the second derivative is the slope of this graph. So the first thing you look for, where is the slope 0? Here, here, and there. And where will that be? They kind of told you in the problem. -1, 1, and 3. So if the graph is coming downhill, the slopes are negative. Uphill, the slope is positive. Downhill, the slope is negative. And then uphill, the slope is positive. But what does this mean? F is concave down, F is concave up, F is concave down. You have to write, some people don't even have anything underneath. It's like what? Then you gotta write paragraphs. You guys are just cutting your throat when you do that. We've been doing this the whole year. So if you write the legend, then you can just do kind of like this thing. Okay, but like I said, I always have the legend there. So now let's answer the question. On what intervals between -3 and 4 is the graph both concave up and decreasing? Just look at your number line. Where is it concave up and decreasing? Except I read it wrong. Concave down and decreasing. Just look at the number line.
-2 to -1.
Okay, -2 to -1. And then some of you don't know what to write. I told you guys, if you don't know what to write, this is the correct symbol. If you don't know what to write, put a comma. Some people are putting the word "and" there, which means no solution. Because "and" means intersection. And what else? Where else?
1 to 3.
1 to 3. And what's your reason? Because
Negative and F double prime.
because F prime is
Negative.
negative and F double prime is negative, right? There you go. Okay, C. Find the x coordinates of all points of inflection on the graph of F and give a reason. Oh, that's easy. Look at this. Look at this number line. Where do you have points of inflection? -1, 1, and 3. Because, what's the reason I'm going to write here, Hernandez? F what? No. F
Right back.
double prime. Changes sign. Exactly. Remember, second derivative tells you concavity. Okay, and then the last part was worth 3 points.
Oh.
This is where you're going to use code red. Now, some of you weren't even using code red. Now, it says, write an expression for f of x that involves an integral. Now, some people didn't even do that, which is fine, because that's not that easy. However, you should be able to find f of 4 and f of -2 and get 2 out of 3, which puts you in rarefied air right there. Okay? So, you know that f of 1 is 3. How do you find f of 4? I'm going to integrate the derivative from
1 to 4.
1 to 4, because you know 1 and you're trying to find 4. So this is equal to f of 4 minus f of 1. This is code red. Or maybe we should just call it the fundamental theorem of calculus part 2. I don't know. Look, so I know this is 3, right? No, this one is 3. How do I compute this? Well, if this is the graph of f prime, the integral from 1 to 4 is the area between the graph and the x-axis. Now, they already told you this area is what? 12. So what is that integral then? Since it's below the x-axis.
Oh, it's negative.
Negative
It's
12.
like, why did you take off points?
You guys, that's like basic. So therefore, what is f of 4 equal to? Negative 12 plus 3, negative 9. Okay, now, how do you compute f of -2? Same thing, you integrate from -2 to 1. Right, because we know 1 and we're trying to find -2. So we're going to integrate f prime, so using the fundamental theorem, this is f of 1 minus f of -2. See how it's kind of switched from the other one? Now we know this is equal to 3. How do I compute that? Well, if this is the graph, from -2 to 1 is this area right there, and it was 9. And since it's below the x-axis, negative
for
9.
that one.
You put the negative one down? It's kind of sad.
What's the answer?
So therefore, just look at it. F of -2 is equal to 3 plus 9, which is 12.
Oh, I reversed it. This one I said, what did I do?
That's a long test.
So now, let's get the last point. Write an expression for f of x. Like, how do you compute f of x? Look at what we did here. No, look at what we did in these two problems. How would I compute f of x? I do an integral from 1 to x of f prime of t dt. Now, you don't have to put t here. If you want to put x, you can. And then what is this equal to? F of x minus f of 1. Well, we already know this is equal to 3. So tell me, what is f of x equal to? Solve for f of x. Wouldn't it be this thing plus 3? So 3 plus the integral from 1 to x of f prime of t dt. See, so just by doing these two, that kind of tells you how to get that one, if you didn't think about it at the beginning of the problem. Okay, and then the last one is, this is implicit differentiation. Okay, what time is it? Oh man! Yeah, well that's okay, we need to take the time because, like I said, this is last year's test. The test really doesn't change that much from one year to another. So if you're going to study just one thing, this is it, right here. This is your Bible. Okay, so now look. It says it can be shown that dy dx is equal to y over 3y squared minus x. So in other words, you don't even have to do the implicit differentiation for the first derivative. Okay, they're telling you what it is. Okay, A. Write an equation for the tangent line. Okay, you have to get these 2 points. Okay, now they tell you the point. How do you find the slope? You plug it into the derivative. So that's 1 over 3 times 1 squared minus negative 1. So that's 1 over 3 plus 1 is 1/4. Who was doing arithmetic wrong, driver?
Sorry.
Y minus 1 equal 1/4. You know, just leave it like this then. Leave it like this. Just leave it like that and don't even write 1 and 1/4. Just put that.
Why did you write this is not an equation?
Because you didn't even write an equation. An equation has to have an equal sign.
I did have an equal sign.
Wait, let me see. You looking at me funny? No!
What?
It says write the equation of the line. You just gave the slope. You only gave the slope. It says write the equation of the line. Oh, you got 1 point at least.
Tired.
What if you're tired on Thursday?
I'm not.
I'm gonna fall asleep during the test. Is it in the morning or the afternoon?
Gosh.
Is it
Morning?
morning afternoon?
It's in the morning.
Oh.
It's always in the morning. Okay, come on, let's do this. Find the coordinates of all points
Oh,
on the curve.
gosh.
We've been doing it this the whole year. We did it on that review at the beginning of the
I
course
didn't get
too.
the slope.
And where the line tangent to the curve is vertical. Here is the derivative.
Do you have to come back to class after the exam?
Only if you don't do the course evaluation. If you, but you cannot do the course evaluation until after you take the AP exam because I'm gonna ask you what you thought about the preparation
So it's the
was.
same day, so we can do
So
it
if you
in
don't do
class,
it,
we can do it
if
in
you don't
class
do it by
after.
Friday, you come into class Friday.
How long does it take?
What?
Wait, what is it?
It's
Is it
not
the
an
one-
essay, no, it always was an essay, except now the administration wants us to do it online and then.
A survey.
So I just gave up
So it's a
already.
multiple choice
It's like-
survey.
So like last year in PCH, didn't we do like one, remember we had two evaluations? One on the
Yeah.
computer and one we typed out an essay.
Mhm.
This year I just gave up already, we're just gonna do it on the computer.
So it's like.
Okay, come on, let's
So
just
if
finish
you didn't
this.
write an essay, it's
Don't worry, I'm
gonna
gonna
be
send you an
essay.
email. So, if this is the derivative, what is the slope of a vertical line?
Undefined.
Undefined. What makes this undefined?
One
The
minute.
denominator gotta be 0. So if you just write this on your paper right there, you got 1 point. You got 1 out of 3 just by writing that on your paper. You're above the Mississippians already. Now, how do I find the points on this curve where that occurs? Solve for one of the variables here, probably x equals 3y squared. Take it and plug it back into the original equation.
Ew.
We've been doing that all year.
That's debatable.
So y cubed minus x, which is 3y squared times y, is equal to 2. So y cubed minus 3y cubed is equal to 2. Negative 2y cubed equals 2. Y cubed is negative 1. Cube root both sides. Y is negative 1. How do I find the x coordinate? Plug it back into there. So x is equal to 3 times negative 1 squared, which is 3, so your answer is 3 comma negative 1. Bam!
It's close.
If you want to find the points on the original curve, you actually got to plug it back into the original curve.
Wait, 0 over 0 undefined?
What?
0 over 0.
Yes, that's undefined. Okay, but there's two questions they're going to ask. They're either going to ask vertical or horizontal, or give you a number. Now, if it's vertical, the denominator got to be 0, got to be undefined. But what if they said this, where the line is horizontal? Then you got to make the numerator 0.
Wait, so can the point 0, 0 be the answer?
No, only the denominator 0.
Oh, okay.
Okay, C, compute the second derivative. Okay, here's the first derivative. Okay, now this part is worth 4 points. Okay, when you do implicit differentiation, we've been talking about this for months. When you take the derivative of x, you're gonna get 1. When you take the derivative of y, you get y prime. And just go at it. So second derivative, I see a quotient, I'm gonna use the quotient rule. So low d high, which is y prime, minus high d low. Now this is like 3 box squared now. 6 box times the derivative of box minus 1. All over denominator squared we go. So if you did that correctly, you just got yourself another point. Well, that's the first
Oh,
point.
damn.
Okay.
And
And then, actually, I think they might give you 2 points for this. Compute the second derivative when x is negative 1 and y is 1. All you have to do now is plug in negative 1 for x and 1 for y. But here's the problem. Mr. Park, what do I plug in for y prime? I don't know. Well, this is y prime right here. So what are we plugging in?
You
We're
wrote it
plugging
above
in
the
negative
problem.
1 for x and 1 for y. So if I plug in that, you get 1 over 4. Yeah, we already did. 1, 4. So you just plug in the numbers, except for this and this, you're going to plug in 1, 4. And if you don't even have to crunch the numbers, you just show that you plugged it in, you're going to get the points. But if you have the balls, 1 over 32 is the answer.
That's gonna work as well. I'm gonna try again.
Okay, we completely went over this test. Like I said, this is the most important thing.
There it is.
No, you guys are going to correct. You guys can correct it yourself. Right here. Why do I have to do all the work?
Because we don't know our cheat codes.
What, you want me to collect it and grade it?
Yes.
Yeah.
Yes.
Are you serious?
Yes, completely.
I don't have a Scantron machine like the other teachers do.
You can ask to borrow.
But you're a pinball wizard.
Okay, you know what? I will. But no, because you know what? I want to
Oh, wait.
I want to discuss some of the problems now that's left. Okay, where did my papers go?
Do you know what pinball wizard is?
Over here.
Yes, it's from the Who.
Nice.
Tommy. Then Elton John did it, redid it again in 1975, I believe.
Woo! Reference. Understood. Alright.
Okay, we still got 10 minutes. Sit down.
That teacher.
Sit down.
You don't need answers.
I don't need answers.
What if you're wrong?
I'm Mr. Park. I don't need answers.
What if you teach us the
Oh,
wrong
there.
thing?
There's answers
But
right
I'm
there.
not-
Why would I
Mr.
teach you the
Park,
wrong
I
way?
answers.
What if I teach you the wrong thing? Yeah. Then I would get fired.
But they would never know that. It
What
was
you know?
Well,
They're just gonna think we're
wait. How would 31 out of 33 students last year get 5s if I didn't teach them the right thing? There was a conspiracy against you, Mr. Park. So they made their own study groups. Okay, somebody had a question.
9.
Number 9.
On A?
Okay, A is no calculator now.
9.
Boo! Okay, when they give you a rational function, for which of the following values of x is f not continuous, it's simply when the denominator is 0. Because think about it. If the denominator is 0, either there's going to be a vertical asymptote or a puka. But in either case, it's not going to be continuous. So the answer is simply 2 and negative 1. Are you paying attention?
Yeah.
Since you asked the question.
Sorry.
You asked the question, you're not paying attention!
I got a lot of wrong.
The function? Yeah, but I thought I'm correcting it.
You are?
I thought that's what you guys agreed on.
Yep.
That's okay, you know what? I'm willing to do the work. I'm willing.
Can you?
So when the denominator is 0, that's when it's not continuous because if the denominator is 0, either there's a puka or a vertical asymptote there. In either case, it's not continuous. So you just simply look, when is the denominator 0? That's the answer. Okay, next. I'm sure you have more questions than that.
I got number 10.
A particle moves along the x-axis with this velocity. So here's the velocity. If the particle is at position, so that means x of 0 is -2. This is code red right here. What is the position at time equal 3? I don't know. I'm going to integrate the velocity from, what limit should I use here? Since I know 0 and want to find 3.
0 and 3?
0 to 3. So that's equal to x of 3 minus x of 0. So we already know this one is equal to -2. All you have to do is compute this integral. So how do you compute this integral? You find the antiderivative, which is t cubed. See, sometimes you can't find the antiderivative. Other times, you either got to look at your calculator or to give you a graph you have to look at. Minus 4t from 0 to 3. So what is that? 27 minus 12 minus 0 minus 0, which is 15. So 15 is equal to x of 3 plus 2. So therefore, what is x of 3? Well, what did you do? Minus -2. So that's all they have to do, and you guys can get faked out by that. Just like you're playing football, all you gotta do is turn your head, and then that goes that way already.
Yeah. Fun.
Okay, come on, we gotta have more questions than that.
I have a question.
Yeah.
17.
That's not
What if the Mississippians think we're like savages that live in huts and they like tease us?
They probably
Don't
do.
be like the Hawaiians. They don't even know how to speak
No,
English.
Hawaii, well,
They don't have electricity.
Iolani and
That's what
Punahou,
people
they
think.
put like the AP average. If it wasn't for us in Punahou, then we could be
Savages.
Mississippi, we could be Mississippi.
17.
Okay, 17. Savages. This is the definition of the derivative!
What's the adjectives they use in Pinball Wizard? I don't remember.
He's a pinball wizard, there has to be a twist. Pinball wizard, that's such a software.
Oh, never mind, I got that.
No, I'm doing it.
Focus on actual sum.
Hey, this is the definition of the derivative.
It's a real sign. I want to play it.
Okay, wait.
Can I play it just like softly?
No,
Yeah.
sit down, Park.
Yeah.
Okay, put that kind of away. I wish I. Look, the AP exam is
I
in
wish
3
I was an
days.
engineer.
No worries,
I
Mr.
started
Park.
making double the
Mr. Park,
money.
I think
But no,
I
I wanted to be a
think I
math
guaranteed
teacher.
my 3 already. Can we just go to sleep? I liked it better when you were sleeping.
I want to go back to sleep.
Which of the following could be the value of A? Okay, now, what is this equal to? Okay, let me call up people. Tanaka.
1 over 1 minus a squared rooted.
That is correct. Everybody got that? Okay, this is the definition of the derivative of what function? Turn it off.
Fine, it's off. Yeah, but now it's off.
Arc sine x. What's the derivative of sine inverse x? 1 over the square root of 1 minus x squared. Except you have to plug in A.
Equals 2.
And they're telling you that's equal to 2. All you have to do is solve for A. That's all you gotta do. Can you guys do it?
Oh my god.
Square both sides. Here, just let me do it. Square both sides, cross multiply. So 4a squared is equal to 3. A squared equals 3/4. A equals plus or minus root 3 over 2.
Circles on my